The video for 912, and in this one it does say, hey, check out the math notes box. So I just went to the end of the in-class work, and what it's talking about here is called pyramids and prisms. And these pyramids and prisms, a prism is is like this sort of a deal, right? Where what it does is it has like a shape. In this case, it's a triangle, and in this case, it's a pentagon. And what it is, it's almost like if you took that thing and you stretched it out and it made a shape, right? A rectangle is also a prism. It's called the rectangular prism. There's a triangular prism, a pentagonal prism, because the base is what we call them. That top or that bottom part is, in this case, that picture has a top or a bottom, is a pentagon. Okay, so a pyramid, though, I think you're probably much more familiar with, right? Something to that effect. It has some sort of base. Now, the name of the pyramid is based off of the side of the type of base. So in this case, this would be a hexagonal because it has 6 sides to it. Okay, so I'm going to go up here, and we have 912, and we're going to talk about how we can visualize nets and surface area. So how we can visualize stuff, and we're going to talk about nets and surface area of shapes, all right? And so this is the last that we talk about in regards to surface area, volume, that sort of thing. As we close out the year, this year has just flown by, even this last quarter. I added this part right in here, and nets are sometimes really hard to visualize. So I created that link, or I didn't create that link. I found that link and I shared that link with you. And that very first link that I shared with you is, I take that back, it's this one. And these are nets of shapes, and they could be really helpful for you as far as your ability to kind of visualize stuff. We're not going to do like nets of a cylinder, but how about I grab that and show you what that looks like? So what you can do is, should load up here. There it is what you can do is you can see what it would be if we cut it and we laid it out flat and then we put it back together. What sort of shapes would that be, right? And so in this case, we did a cylinder. You could also do it for a cone, right? What does that look like? And it's sometimes odd for you to visualize what that is. So in this one, this one's a lot of fun, but I have another one that would work out really well for that, is nets of a cube. And you can see how these cubes come from like this to this, and there's other options for us to select. Okay, so anyway, how do I get there we go. And then some of the other ones that you're going to see here, nets of a cube. This one is also nice too. It has different patterns for you to look at. Come on. All right, must just need to load up here for a moment. Load up. And it's not letting me select them right now. I know it should work here because I've used it previously, but you can have different patterns and then you can open and close them. And then the same thing here for a rectangular prism, where it's much more like the cube type thing, but you can also do some things where that you have the open, close, rotation, dimensions of it. Are there certain dimensions that you'd kind of want to do to help you visualize stuff? And then lastly, a pyramid, and you can mess with the distances here, and you can open and close that pyramid, okay? For some reason, it's just not loading up quite that fast for me right now. Let me see. Whoops. Get out of here. I wondered if closing. I wondered if closing this would help. It does work because I've had a few other students test it out. So please you lean on these, use them to help you understand and feel better with nets. Okay. So back here, take a look at that stuff. So this first one, it says your teacher will show you a cardboard box. I gave you that first cube one that you can kind of manipulate. And what would it look like if it were unfolded and flattened out? And I don't have that box in front of me to be able to show you guys. So what I did is I used that net to do that. Why don't you just take a second and just kind of draw a picture of what you think it would look like before it happens? And I know, I guess I kind of cheated by giving you some of that. So then it says, picture in your mind each figure below. There are, by the way, a multitude of options under pictures that you could draw that still create a cube. I just want you to know there's no technically right answer, but you should find one of them hopefully in there. Okay. Now, picture in your mind each figure below as a three-dimensional object. What would each shape look like if it were unfolded so that each face, now there's faces are all these flat sides of anything, was flat on the table, like I kind of already had, like I said, cheated and showed you before. A flat picture that can be folded up to form a three-dimensional solid is called a net. And that net is what it would look like if it were all flattened out. Now draw a net for each of the shapes below, and let's see what we have. So because there's a ton of other ideas, I will say, like, what if you took this top part, right, and I drew the very top flat like this? Well, what I'm going to do is I'm going to draw the back part right here. And then I have the bottom, and then here's the front face. And what I've done is ignored the size for a second, and all I did was I just took all of that and I flattened that out. Just flatten that all out. And then these sides, right? These sides have to be attached somewhere, so I could just put them here, couldn't I? Right? I could just attach them anywhere on there, and that's what we call a net. A pyramid would be, in this case, a hexagonal one, right? So we would look at the hexagon that's drawn from there, and then each of those top pieces just kind of fold out, right, to create what? A triangle. There we go. Okay, something to that effect. Play with those pyramid nets. Take a look at that, okay? All right, so now what we have is now I'm going to say, hey, we're giving you some of these nets. How can you tell about a shape from using its net? In this challenge, right, you're going to work with the team to say what would it be, completely try to see what would it be without actually, putting that together, right? So I gave you some resources here, nets of pyramids and nets of rectangular prisms to help you with all of these, okay? So in this one, what would net A bring? That would bring us a cube. And it's going to be one of the options that you can find under the cube one from earlier, okay? Then net B, I kind of already showed you that one from previously. That's going to be that pyramid one, right? That's just a pyramid. In this case, what kind of pyramid? It looks like it's going to be a square or quadrilateral pyramid, right? Square, much like the pyramids that you'd see in Egypt. This one is going to be a rectangular pyramid. And where does that all come from? That all comes from the fact that you can see that it's a rectangular base, and that rectangular base is um, that rectangular base or whatever, I guess you could say, and it gets all stretched out, right? So this one would look something like this, wouldn't it? Something to that effect, right? Rectangular pyramid. I said pyramid. I'm sorry. That should be not a pyramid, right? But that should be a prism. There we go. And then the last one would be, looks like a one, two, three, four, five, six-sided. So that's a hexagonal pyramid. And I cannot encourage you enough. These can be very difficult to see. I can see them very easily. I have that type of mind, maybe, that visualizes that stuff well, but by no means will everybody have that. So, again, I cannot emphasize enough for those of you who struggle, play around with all of these shapes. Go online and type in like an interactive net and type in a shape and like a pyramid or prism and stuff, and you should find hopefully some more. Okay. So, do you remember Carly and Stella from lesson 911? They were designing that office building, right? And then we had from before. So these floor plans are shown below, much like we have. But remember that we had to have at least 100 and no more than 195 um, cubes, cubics, or I think they had a different name for it or whatever, that could be in there, right? So that meant that if we had this layout, we could only have 19 stories. If we had this layout, we could have 24 stories, and the rest of them were 32, 32, and 32. Okay. So Carlene's telling I want to make lateral faces of the whole building entirely out of glass. The lateral faces are the sides that are not the floor or roof. How much glass will they need for their building? Assume that they use the floor plan your teacher assigned you and the height you found in problem 9-3, which is indicated below each plan. Be prepared to explain your result in your class. So what I'm going to do is let me just zoom in and show you what we're talking about. Okay, you have to picture this three-dimensional shape sitting in front of you. And what would be a good color? Maybe something like this teal here. It might be easy for us to see. And right here, this face right here is one lateral face. Here's another one. There's another one. Here's another one. Here's another one. And we go all the way around the shape right here. Right there is one. Then we have one that's going to be right here, another one there, and then another one on the back side, right? So we have a total of 8 lateral faces on there, right? 8 lateral faces. So it's like a building where its roof is not glass. The floor is obviously not glass, but every single thing other than that is glass, right? The outside parts are glass, something that we'd see in a movie, right? So this one also has lateral faces. There's one here on the edge, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14 different ones for this one, right? 14, what was this one? 8, I did write that number down. Again, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 14. Moving up. Now, with this one, what we hopefully we start to do is there's patterns for this, right? There's going to be 4 on this side and 3 here, another 3 up here, and 4 here. But we also cannot forget about the inside now. So we got 1, in fact, I could just write 1 here, 1 over here, 2 on this side, and 2 on this side. And what we can do is just count all of those up, right? And so 4 and 3, 7, another 3 and 4, 7, so 14, and then plus the inside, 14 plus 6, 20. And we can shift over one, and what we have, this one's really nice, 3, 3, 3, 3, 1, 1, 1, 1. So 12, 12 in the 4 is 16. Okay, so those helped kind of do that. Now, all this was for one floor. So first floor. And let's just talk first floor. We have pattern 1, 2, 3, 4, and then 5, right? And we have all those patterns, and we had for floor 120 and 16 and 14 and 14 and 8, right? And now what we really need to do is, what is it for 19, 24, 32, etc. So what you're going to do is just multiply this by 19, and you're going to have your total. And you're going to multiply that 16 by how many? 24 stories, right? 24 stories, so times 24. And when we do that, we'll get all of those answers that we are looking for this one, right? And all right, and we have, this one turns out to be 380 square units, right? This is area. This one becomes 384, and then this one becomes 448. Number 4 becomes also 448, and the last one becomes 320. Again, all of these are square units. I just didn't have that space to fit that in. Okay? All right. So surface area is the number of squares it takes to wrap around the entire outside of it or surface of a three-dimensional object, including the top and bottom. So it is exactly like we had up above, but now I want you to count the floor and ceiling. That's the only difference between those lateral faces and then finding all of the surface area. So visualize that wrapping paper, the rectangular prism, with that rectangular prism that we see here on the right, with 1 centimeter grid paper. Why 1 centimeter grid paper? Because we are using centimeters. How many square centimeters would be wrapped around this prism? What's the surface of the prism? Okay, so to do something like this, I find that it's really nice to organize that data, organize it by a front and a back, kind of looks like front and back, and then a left and a right, and then I like a top and a bottom. And I'm hoping this will make sense here in a moment. So if we look at the front and back, I'm just going to highlight that front and back. And let's go with, all right, we're going with that orange. Here we go. So the front, let's just look at that front part right here, right? The front part is just merely a rectangle that is a 6 by 7. So if we talk about the front is what? 42 square centimeters. Well, what's the back, right? That's the front. Right? What about the back? The back is the exact same shape. That's why I paired them up this way. It's 42 square centimeters. Well, what about our left and right? Well, let's choose another flavor, right? Another color would be maybe a purple, huh? Let's use purple. And under here, right, let's just visualize that side. Well, we take our square, rectangle, I mean, and we put that here. And what do we got? We have a 3 on the bottom, but what's the other dimension on there? Well, since this 6 here, we follow that over, that would be 6. So this is also 6. So then this one become 18 square centimeters. And that's just the left one, right? Well, what about the right? Same deal, right? And that would be 6 and 3 for 18 square centimeters. So we've accomplished 4 of the 6 faces. Okay, so now our top and bottom. Let's take a look at the top. Let's just choose another color for that one. We will choose green, and here we go. Now that top one right here, right, that is this piece up here, and what we've got is this part right here is a length of 7, and this length based off of what we have is 3. Follow that 3, right? That 3 is up here, and that's that 3 there. So we have a top and bottom of a 7 by 3 for what? 21 square centimeters. And then we have the other one is also 21 square centimeters. Didn't even draw it out, huh? So what we have is we have our 6 faces, and we're just going to take those 6 faces, and we are going to add all of those up. We're just going to add all of those up. So 1, 2, 3, 4, 5, 6. When we add all of those up, we are going to get a total of 162 square centimeters. Or we could write it as 162 centimeter, sorry, square centimeters. Okay. All right. So there we go. Now for 9-20, what we have is I just told you you can't do this problem because I can't share the paper. So if I shared the nets with you that you received in 9-17 and they were cut and folded to create solids, which of the solids would have the greatest surface area? Write down your team's prediction along with justification, blah, 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 moving along. Now let's go back up. Let me just show you what it's asking you to do. It's asking for these 4 problems right here, but I don't have the printed paper that I'm going to give to you and have you measure and guess and whatever. So all I'm going to say is don't worry about the problem. Just think about it, right? Just think about what that would be. How would you find that, right? And actually, if we go back up here, I think the only part we'd have to do is you've got to find the area of each of these squares here. This one you got to find for B, you just need to find the area of the square, right? But then you also got to find the area of each of those triangles. In that C, you have to find the area of that square, which is the same as that one, and then find one of the rectangles. And excuse me, they're all the same. And then for D, you just get this part, which maybe we'd have to teach you how to do that, and then these triangles, right? Okay, so we got to be just about done. Think about it, right? Think about it. What would you do and whatnot? So the rest of these are all extra problems, except for the learning log. Again, please write. You have no idea how powerful that is. Please, 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 just take a second. Set a timer for 2 minutes, 3 minutes. That's it, and just write. What do you think about that? Okay. All right. Be sure you check out math notes. Right now, I'm just going to go over the extra problems if you want to pay attention and go along with those. Okay. Carly and Stella designed a garden shed for their families. They want to build a total of 4 sheds, but they will use the same design for each one. The shed design is the shape of the triangular prism. They drew the net below. They plan to paint the outside of the walls, the roof, and the inside floor with the same paint. Each surface they paint will actually need 3 coats of paint. The label of the paint states coverage 70 square feet with 2 coats. Work with your team to find out how much Carly and Stella should buy. You know what? I didn't work through all this yet, but well, how about I just say this? Wouldn't 1 coat, well, 75 square feet with 2 coats. So 1 coat is 35 square feet, right? And 2 coats would be 70 square feet. Well, I guess I could really say covered 70 square feet with 2 coats. Ultimately, I take that back. What I could really say, I don't know if that's not really the best way I want to say it, but ultimately, what does it cover? Each can covers 140 square feet, right? Because if it goes over the inside once, and it does it a second time, or I mean, it goes over 70 square feet once, and then a second coat, that means it can do 140 square feet total, right? It can cover. So let's find the area of each of these. Area of any triangle is base times height. Triangle, right? Triangle is base times height, and divide that by 2. The base of every triangle is 16, and the height of that is 6. And then we'll divide that by 2. 16 and 6, right, is 96. So 96 divided by 2 is 48. Oops, sorry about that. So the triangle is 48 square feet, but that is the front and the back, or the front or the back, not both of them. So I just need to multiply it by 2 to get the total. So front and back is 96 square feet. Now let's just do the floors and the walls. And it looks like if I kind of follow these, right, this 16, if I were to fold that up, that one's also 16. This is not annoying. Huh? Sorry about that again. That's also 16, and then this one would also be 16. So each of these rectangles are the same. They are an 8 by 16. So I'm just gonna say the 3 rectangles. So 3 rectangles, right? Those are 8 by 16. 8 times 16, so 16 times 8, right? 8, 4, 12, 128. And we've got 128. But I need to multiply it by 3 because I have 3 of them for a total of 128 times 3. 4, 2, 8, 3, 384. Please make sure I'm doing these right because you never know. Mr. Krohn could totally go too fast or mess up or something like that, right? So when we add all of that up, we should get 400. Yeah, we will. 96 plus 384. We're going to get a total of 480 square feet. Well, remember that paint pan. Holy cow! 140 square feet for each paint can. So what we're going to do is we're just going to divide that. We're going to divide that by let me make sure I'm doing that right. Well, I don't want to divide it necessarily by 140, but because what it's doing is, if I divide it by 140, remember I want up here, where did they write that? We'll need 3 coats of paint. So instead, what I'd say is instead of doing 480 square feet to figure out how much I have, I'm going to do that 480 and I'm going to multiply it by 3. Okay, now let's think about this for a second. That's the square feet for the whole thing. That's just the inside for 1 coat, but I need 3 coats. So 480, right, times that 3 will give me 1,440. But now I need to take that 1,440 and I'm going to divide it by what? 140 because that's how much each can covers, right? That's how much each can covers. So when I do that, and I divide that, that will turn out to be, this one turns out to be a decimal. Feel free to just use a calculator to do that. 14.14 cans. So I'm going to have, I'm sorry, not 14, 41, 41 cans times 12 coats. Oh, because they're doing inside it. It says by 12 coats. Did I make a mistake here? The shed design is the shape of the triangular prism. They drew the net below. They plan to paint the outside of the walls, the roof, and the inside floor with the same paint. Each surface they paint will actually need 3 coats, right? So that's what we did, 1,440. And it says 70 square feet with 2 coats. So that's 140. For some reason, they multiply by 12 coats, and I cannot understand why. Something doesn't seem right. Something doesn't seem right, and I don't know what's going on here. 1440 divided by 3. I'm going to stick to this, or I'm going to stick with my original values here. And it should be, something doesn't quite seem right. I don't know why they do it 12 times. It feels like when you check the answers, it'll see a 12. It looks like it should be just those 3 times. So then when we do that, I should have 10. The answers are wrong here. 10.2829 it rounds to. Okay, so 11 cans. I don't know why they have what they have there. All right, lastly, Carly and Stella's latest office building design is the shape of a pyramid with a rectangular base. Like the French name of something I cannot pronounce, it is built entirely of glass, including the floor. That's impressive. The dimensions of the design are shown in the diagram. How much glass do they need to buy? That is another way of asking you to determine the surface area of the perimeter. So just the pyramid, sorry. So just look at the base. The base is what? A 15.8 times an 11.4. We find the area of that part right there. And then we need to find the area of the triangle. Now notice there's 2 different types of triangle. There's a front triangle that is given here with a base of 15.8, but then the right triangle has a base of 11.4. The left and the right are the same, the front and the back are the same. So the front triangle, right, looks like this. It has 21, a height of 21, and a 15.8. And then the left and right one has a triangle of base of 11.4, but with a height of 21.7. Find the area of the left triangle, find the area of the right triangle, find the area of the base, and then add all of that up. And we should have 759.3 square meters. Now, I went through that quickly just to keep the video short. If you have additional questions on that, I'm more than happy to help you and dive a little deeper. All right, if you have anything else, please let me know.